Good morning, Hamburg. My name is Harshvardhan Karn, and he's my friend and colleague Sumit Lalwani. We work for Maya Data, the Maya Data, which company which sponsors OpenEVS Sandbox CNCF project. So, so today our talk is based on how we actually created a Kubernetes cluster using ARM cluster, these Raspberry Pis, and how we did a network benchmarking performance test over this one using a couple of tools. We actually evaluated CNI plugins using a couple of tools on certain protocols. So our agenda today will cover the introduction part of our experiment or test we can call, and then we will switch to why we actually used ARM instead of AMD or the traditional machines we have been using since years. And then we will discuss about the CNI plugins that we use in this test and the tools, and then the results. We will have a graph, we will have a comparison chart, then we can conclude, we can come upon some results, and then my friend Sumit will give you a small demonstration how we actually carried out this test and under which environment and what were the factors that were affecting this test. So let's jump to the introduction. Uh, I'll start with the thing why we actually did this test. So in our company, OpenAVS, we had lots of CI/CD pipelines that were running on multi-noded Kubernetes cluster that were actually pretty large machines, but the jobs we were doing were not that large. So we tried switching this to ARM thing because, there are reasons we use ARM. It's low power consumption and all. And these small jobs, cron jobs and all can be ran over there's a small cluster instead of learning in the big cluster somewhere else and paying them too much. So this were our basic idea. So the problems user were actually facing, the OpenAVS users, that okay, it's good we have a cluster. Then what about networking? How good is networking in that cluster? How fast is networking? Where is the charts? How we know that it's good, this CNI plugin is good or that CNI plugin is good? So basically we came up with a method. It's not an end result. We are not giving any conclusion that what is better, which one is not better. We are just giving you a process how you can test this on your own cluster, which tools you can use, and what are the ways and what are the ways you can calculate or you can conclude that which one is better for your setup. So why ARM? It's a very there will be a way, if I just give you an answer directly, it would be a vague answer. But let me just tell you why ARM, why actually we used it, not why you should use it. So ARM is a small device which is like inexpensive. You can get it under 35 bucks since now Raspberry Pi 4 is also released, which is not too much of cost. It is power efficient also. By power efficient, I mean it won't consume lots of energy. It won't cost you too much on your bills, and it's great. Simply, I like for an ARM enthusiast and Kubernetes enthusiast. This whole combining of Kubernetes with ARM is just magical. For me, it's so now let's talk about our setup. What kind of setup, what kind of environment we ran tests on. So basically, we were using this small nodes cluster. This is a Raspberry Pi 3B+. We have set up one cluster in our Bangalore office in India. And we just brought these pieces to show you what we are using. It has 16 gigabytes of SD card in it. So we have a cluster there. The more detailed information my friend Sumit can tell you because he has been working on this since couple of months.
Okay. Am I audible? Hello. Am I audible now? Yeah. So the Kubernetes cluster like we have is consists of one master and two worker nodes that all are running on this small Raspberry Pi, which like will be performing benchmark tests on this cluster. So It's in our office, so it is basically exposed on a port so that we can access through the internet now to perform tests. In the demonstration, I'll show you the test, basically how we performed a small demo, kind of 1 or 2 tests, depending on the time we have. Um, yeah, so all the tests running in that cluster, so we have ran tests on different nodes so that we can get the pods networking speed, basically bandwidth, as CNI plugins is mostly for the pod networking, right? So the server and client concept is here. We run the server in one node as a pod and client on another node, and we'll test some performance. So, uh, so what test we are performed is like we decided to have some most widely used protocols like TCP, UDP, STTP, and SCP for performing tests. And so it was also difficult, not difficult, but there are many tools to perform this test. So one of the most popular is iPerf. Its version 3 now has been there, and which performs the TCP and UDP test. And iPerf 3 is ARM supported. Actually, they gives the ARM binary. So to run that on Kubernetes, just we wrote the Docker file to generate the image and install that binary so that we can run. I'll show you the Docker file also. And for STTP, we have curl and Nginx. Like Nginx will serve one file in the server, basically in one node, and the other node will download that file in the path which like Nginx has exposed, and we'll see the test result, basically the speed and the bandwidth between the two node pods that are running on different nodes. And SCP OpenSSH we have used, it's the most famous one. And we have also built the image for this also to install on the Debian OS, that install OpenSSH server and client so that we can use SCP to download the file basically from one node to another. So these are our tests. Yeah.
So let's see the test results, what we got using that tool that Sumit explained. We will have a graphical view of all the results.
One second.
So this is using iPerf tool. We tested TCP for VBNet, Flannel, and kubeproxy. So it's not, we are not like just thought we will take these three also only. You can take anyone. Like there are multiple CNI plugins, and all are awesome. I can't conclude that. I cannot tell you that which one is better because lots of effort has been put down to make those. And it all depends upon your use cases, like what is your use cases, what is your environment, and what you want to use. Let's say in that case, in using iPerf 3, this TCP results, you can see here that the graphs here are, in the y-axis, it's megabyte per second, and in the x-axis, it's number of tests we carried on. So there were 10 test runs we did, and these are the results. So here, clearly, kubeproxy had a better megabits per second in compared to VBNet and Flannel. And then for UDP using iPerf 3 again, we got this result. And x-axis and y-axis are the same that was in the previous slide.
One second.
And then we did an HTTP test using CURL and Nginx. We had CURL running in one pod in another node, and then Nginx running in one pod in another node, and then we did a CURL of 200 megabytes of file from one node to another node using a standard network, and then we got this results. And for the SCP, we used OpenSSH, which is widely used. We used in almost every SSH, we use this OpenSSH. So we thought of using this one only. And this is the result, where Flannel seems to have good megabytes in first and third. And in second, we had VBNet as a good megabytes per second. So a better option. Which one of them is actually better? We can't really compare on the basis of my test results because my use case could be different, my test environment could be different, my bandwidth could be different. So I can't really just conclude that this one is better than this one. We are just providing your process, just how you can test your CNI plugin over your network. Not we are giving you any end results that you should use this one or you shouldn't use this one. Let's say in case of VNet encrypted network, the bandwidth could be really, really low in compared to other cube proxy, cube router, or anyone. But that doesn't mean that's not a good option. It could be good option if your use case is somewhere close to encrypting a network or and all. The problem or challenge which we faced during this test, like I wrote here, is we didn't really face too much of problem except that this ARM community is still budding and there's not too much of resources available online. When we started, we wanted to have an article where we should know how we created a cluster, how we should create a cluster, how we use ARM. So most of the things were self-taught exploration. And then there are a couple of blogs online. They are not too much, but they are limited, but they are great. And another challenge was this one. From this version, Raspberry Pi 3B Plus, it's a 64-bit architecture, but the problem is the official Raspbian image is still 32-bit. So we had to use this 32-bit. Initially, the problem happened when we started doing this work. We started in a packet node. We did have a packet node of 60, ARM64. We built all the binaries and all over that machine, and then we switched to Raspberry Pi. Now the problem is that is 64-bit, and the Raspberry Pi we are using had a 32-bit operating system. We really had a problem there, so we had to rebuild our binaries for this platform. We were searching if there is an option of having a Raspberry Pi, Raspbian 64-bit, but there wasn't any official image, so we didn't use it. Actually, we also tried building our own image for Raspbian 64-bit, and then we slightly succeeded. So now
Yeah.
let's talk about demonstration. Sumit will give you a demonstration how we carried out all the tests.
So we'll see some tests, like how we carried out the test. So here is I have already SSH into my machine, which is running on the office. So if we see, mm, oh, yeah, so here it's a little bit slow. So you can see if I do the get nodes, we get the Kubernetes cluster like nodes with one master and two worker. This all are running in the Raspberry Pi itself. And so we'll see the TCP and UDP test using iPerf. So I have already the YAMLs prepared for this. And you can also get this all YAMLs in the GitHub repo. We'll share the link later. Uh, so first of all, I'll run the server, iPerf server. So here is the YAML. You can see it's a deployment. And the image we are using is my image. I have already built the image, like installed the binary in that. And it's running on the 5201 port. And yeah. So I'll apply this iPerf deployment, which is the server. So if I do a get pods, it's container creating. Yeah, so the server is running. So now it's time to run the client so that we can see the performance results. So first I'll show you the, so this is the client basically. So we have to pass the argument like pod IP. So here we'll enter the pod IP and the Kubernetes host name. So we'll first see the server, which node it is running. So this server is running on worker 1. So we'll run the client on worker 2 basically to test the pod network. And this is the IP which we have to give to the client so that they can access the server. Yeah, and also the host name, I'll change it to the second node because already server is running on the first worker node. So the client is running. I'm container creating. Okay, so server and client are on two different nodes on pods. So let's see the result. We'll get the results in the logs itself. Yes. So here are the results. This is the 10-second test. So this is the output of each second you will get the bandwidth. And this is the, from this itself we have created a graph. So it totally depends on the network that we use. So this bandwidth is based on our network that we use. So yeah, this is the TCP one. So it's a little bit slow. We can see the UDP also. So the pod has been completed. Also, here also we have to mention the pod IP of the server, and also minus U denotes that it's the UDP, and minus B denotes that the limit of the like bandwidth, how much maximum it can go. So 0 defines infinity, it can go like any. So it's running UDP1, and we can see the logs of this pod. Yeah. So this is the test, and I perf done. These are the result of this UDP test. So it's high. This is the transfer which that did, and this is the bandwidth. This is the 10-second test, and the result of 1 second each. So next.
So this was a demo. We did same test using this using the same process. We did SCP and all tests, and then that CURL test. Yeah. Sorry, I can't hear you. Uh,
I think you did not switch the second configuration file to worker node 2.
Yeah.
So that's why the bandwidth is probably much higher, because it's running locally. When you do a get pot minus O wide,
Okay. Yes. Oh, so the
they're
node is
both running
same.
on the same node.
Yeah,
That's what I want
okay.
to say.
Sorry. I forgot to change the node. So we can change the node basically. Okay. So I'll delete the pod. So they're on two different nodes now. Can't- Now let's see the results. Yeah. Thanks. Okay.
cool. Now the conclusion part.
So
Sorry. Yeah.
yeah. Sorry. Yes. Yeah.
Yeah.
Yeah, that's the UDP, right? That's the UDP test. You cannot wait for the like response, right? That's the UDP. That's why it's fast. अरे भाई.
So now, let's jump to the conclusion. Already, I told you that our tests have can be in an environment which you do not prefer, or our test could use cases could be different. So we can't really tell you what is better option, but we just showed you the process how we can test all the CNI plugins over ARM cluster and all. uh, what we will do after this talk. What are our next goal using ARM, or what are our next goal for the experiment we usually perform? Next thing we are going to do is we will rebuild Open EVS for ARM thing. It would be a good storage option in ARM. Like most of the users I have seen, they are using homegrown cluster inside their home for their couple of hobby projects and all. They need a good storage option. So we will rebuild OpenEVS. We will have a storage benchmarking test also. Maybe we can compare OpenEVS versus Rook in the next talk. And then we had an interesting idea of testing, doing a chaos on ARM. I haven't seen a lot of chaos yet done on this platform because it's still a budding, still a new platform. So maybe we can unleash the monkey on ARM. Maybe you can use Litmus or other tools that could perform chaos on ARM. We can do a resiliency test and all. And then there's a new segment where usually ARM processors are not that much sophisticated, not that much stronger that you can run ML jobs on it. But we can really try Kubernetes plus machine learning plus ARM. It could be a good project. It could be a good learning for us. And then I told you before that we tried rebuilding Raspbian 64 bits, but we were slightly successful by slight, yeah. We were slightly successful in building that thing, but it didn't work. Actually, the peripherals we were connecting in the USB wasn't working, and we didn't have too much time. So now we can focus on rebuilding that thing before the official release comes. Or if it's come, it's of no use then. Now, any questions you want to ask?
Also, the test that you saw we have given, like it was performed on the Cube Router CNI plugin. If you are,
So if you have any quick question, you can ask now, or maybe we can, yeah.
What about others, plugins like Calico or some?
Yeah, yeah, definitely. See, there are lots of options for CNI. Actually, the problem with Calico was it wasn't available for ARM, is it?
yeah, maybe it was not available for the ARM, so we tried to build Calico. Also, we tried to build Cilium. We are on the process. We have started things in the ARM, and we are also learning the things. So yeah, maybe we'll come. Maybe Calico was for ARM 64, if I remember. So we tried to build it for ARM 32, as we have the 32-bit OS. So yeah.
So to begin with, we took that 3 CNI which just showed, and so it's kind of a process we are illustrating how we did the evaluation in the CNI. Maybe you can have your own CNI. Like there are lots of options, right? So if they are available for Raspberry Pis 32 bits, we can test it. Any questions? If you have any questions, you can ask now, or I will be available roaming somewhere at the booth. We can talk, we can discuss about the ARM thing. Like, we are greatest fan of ARM if we conclude this talk. So, any ARM enthusiast here? Yeah. Yeah, sir, I can see you on the t-shirt. You run K8s on ARM. Seems like. Okay, so we'll wrap up our talk here. We can meet somewhere if we have any long discussion about this. If you are doing something interesting on ARM, we should know. Let us know. Thank you.
Yeah, thank you.